Hi, welcome back to my YouTube channel. In today's video, we're going to look at problems from sequences and series. And if you don't already know, my name is Animok Abdul Wahab, and I'm a college math instructor. Now, if you're new to this channel, make sure you do subscribe. There'll be amazing videos that will be coming up on this channel on different types of topics, especially topics that have to do with general mathematics. So we're going to look at sequence and series. We're going to look at other topics like binomial expansion and so on and so forth. We've already done a little bit of problems on quadratic equations as well as set theory, but there will be more problems that would look at under quadratic equations later on, some simple tricks that you need to learn. So this channel is packed with a lot of value. So if you find this particular video interesting, make sure you do like and subscribe to the channel to help it grow so that other students like you can benefit from the knowledge. Okay, let's get started into this. So today's topic is about sequence, arithmetic sequence and geometric sequence, frankly. But we'll discuss sequence and series in general, then we'll specifically narrow down to arithmetic and geometric sequence. Now, what are arithmetic and geometric sequences? They are a type of recurrence sequence. And what we mean by recurrence sequence? Recurrence means what? A sequence in which the current term depends on the previous terms, right? So an example is this. So let's say I have a sequence with the general term an, then if the sequence depends on the nth minus 1th term, then this would be a recurrent sequence. Let's say the first term is given as 1, and then we can get any other term in this sequence by following this recurrence relation. Okay, this is called a recurrence relation. Okay, so let's say you want to get A2, you need to know A1 because when n is equal to 2, when you substitute n equal to 2 here, you get A2, and you now have 3 times A2 minus 1, which is 1, A1 plus 2, and this will give you 3 times 1 plus 2, which is 5. And this is how you're going to get all the other terms in this sequence. Now that you know A2, you can get A3, and now that you know A3, you can get A4, and so on and so forth. So arithmetic sequence and geometric sequences are similar in nature, right? They are also a recurrence relation, right? It's a recurrence sequence. And let's look at arithmetic sequence first. Now, we say a sequence is arithmetic. So in this way, this is how we represent the sequence. So let's just look at an example to illustrate this. Let's say you have this sequence. Now when you observe this sequence, you notice that the difference between two successive terms are always the same, right? And this is called the term-to-term rule. And later on, we'll learn that this is what we call the common difference, okay? So you see that what the difference between the second term and the first term is equal to the difference between the third term and the second term, equal to the difference between the fourth term and the third term, and so on and so forth, okay? Now, when you observe this about a sequence, the sequence is called an arithmetic sequence, which means for the property is this: when A2 minus A1 is equal to a fixed number, which will also be the same thing as the difference between the third term and the second term, which is the same as the difference between the fourth term and the third term, and so on and so forth. So this continues to infinitely many number of terms. Okay. Now, what does this mean? This means that from the first equation, it means that we can write A2 as what? A1 plus D. Okay, when you take A1 to this side. Okay, and similarly, you can write A3 as what? A2 plus what? D, because you know that your A2 is now A1 plus D. When you substitute that, that will give you A1 plus D plus one more D, that will give you A1 plus 2D. Okay, now when you follow up this particular induction, so by inductive proof or inductively, you would see that what? A4 is also A3 plus D, which will now end up being A1 plus 3D. Now, in general, by following the inductive proof, we can show that what? When you observe how these expressions are, you would notice that what? AN could be written as what? A1 as well, plus when we reduce this n by 1, you can see 4 is reduced by 1 here, and we have 3. 3 is reduced by 1 here, and we have 2. So the same thing, n minus 1d. And this gives us the general term of any arithmetic sequence. Now, what this means is, for example, the sequence that we're looking at, 1, 3, 5, 7, 11, and so on and so forth. Let's say I want to find the 10th term of this sequence, right? You know, now that I'm writing this sequence, I've not written it up to the 10th term, so I don't know. But with this general term, because it's an arithmetic sequence, how do I know? Because the difference between the second term and the, how do I know it's an arithmetic sequence? Basically, if I know that if I check and I see that these properties are observed, and this property is true, like the difference between two successive terms is always a constant. In this case, the constant is 2. If you observe 3 minus 1, you have 2. 5 minus 3, you have 2. So once you observe this, and it's true for all the terms that you are given in this sequence, then you know that the sequence is arithmetic. Okay, it's an arithmetic sequence. Sometimes it is given to you in the problem. Sometimes you'll be given that your sequence is arithmetic, and they would give you some of the properties, some terms in the arithmetic sequence, or some knowns, and then from those knowns, you then calculate the unknowns. Now, for this particular problem, we are looking for A10, right? Don't forget the formula. A10 from this formula is going to be A1 plus 10 minus 1 times D, right? So always use your formulas. So it's very crucial to memorize these formulas and know how to use them, okay? So A1 is usually actually the first term. So A1 is the first term. We can get it from this sequence is 1, okay? What is the common difference, which is what I was referring to, is going to be 2. And you can take the difference between any two successive terms to get this common difference. Now let's substitute here. That means your A1 is 1, and then plus 9 times D. So make sure that you don't make mistake. Most students would make mistake and add this 1 to 9 first. No, right? What you do from here is you multiply this 9 with the common difference first before you add the first term to it. So it will be 9 times 2. So that will be 1 plus 18, and that will give us 19. So it tells us that in this sequence, the 10th term here is 19. So this will be the 10th term. So this is the first one, this is the second, this is the third, and when you continue, the 10th one will be 19. Okay, that's what it means. Now, so this is one of the first crucial formulas that you need to know. Now, the second one, which we're not going to get into the proof, is called the sum of the first n terms. Now, what does this mean? It means that if I add all the terms from the first term up to a certain n, right, this sum would give us n over 2 times A1 plus n minus 1 times D. So this is the formula. It's either this or the other one, which is A1 plus AN. Okay. Now these are the, so you need to also memorize this formula. They will come very handy in solving problems that have to do with arithmetic sequence. Now, what does this mean? So let's go back to the examples that we have. So we have 1, 3, 5, 9, 11, and so on and so forth. Now, let's just practicalize this. Let's say I ask you to find the sum of the first 4 terms of this sequence. What will you do? You would add the first term plus the second term, plus the third term, plus the fourth term. This is what it means, the sum of the first consecutive terms. So this is the sum of first and consecutive terms. Okay. Now here, A1, A2, A3, A4, when we add this will be 1 plus 3 plus 5 plus 9. It's evident, right? This is the first term, this is the second one, this is the third one, and this is the fourth one. Now, when I add this, that will give me 4 plus 5, that is 9, 9 plus 9, that is what? 18. So I have 18. Now, let's use our formula and see. So our formula says S4, using the first one, says what? The number of terms, which is 4 over 2 times 2 times the first term, which is 1, plus n minus 1, which is 4 minus 1, times the common difference, which is 2. Don't forget the second common difference is 2 in this problem. Now, how do you evaluate this? Look how I'm going to do it. Please be very careful with this. The first thing is that you multiply this 2 times 1. That will give us 2. The next thing is that what? You do 4 minus 1, which is what? 3. Now, multiply by 2. So you have to multiply this 2 first before you add this other one to it, okay? So 4 divided by 2 is 2. We have 2 plus 6, and that will give us 8 plus 8 times 2, that will be 16. So, am I missing something here? Because it seems like the answers are not the same. So let me see. I have 4, 1 plus 3 plus 5 plus 9. Okay. Let's see. Did I make a mistake anywhere? Oh, okay. Yeah, okay, there's a mistake here. Here's 7, here's 9, and here's 11. Okay, so this is going to be times plus 7, not plus 9. All right, so that will be 9 plus 7, that will be 16, right? So the answer is 16, basically. So I could use the formula to get 16 as well, or I could use the other formula, which says is n over 2, which is 4 over 2, a1, which is 1, plus an, which is, what is an? N is 4, right? So that will be a4. So what is a4? We can see is what? 7. So usually, if you know the term that you are adding up to, then it is easier to use the second formula. But if you don't know the nth term, it's better to use this particular one, okay? So it depends on the knowns that you have in the problem that will determine which formula would be necessary for you to use. So this will give us 2 times 8, and that will give us 16, okay? That will be 16. All right, so this is how arithmetic sequence works. This is the nth term, and this is the sum of the first n terms. Now let's move to geometric sequence. We also said geometric sequence. We also said the geometric sequence is a type of, so just a second. All right. We also said the geometric sequence is a type of recurrence sequence. And what type of recurrence sequence is that? So let's denote this by Bn, right? Although we could also use An, just to differentiate both, let's use Bn, is this geometric sequence. Now, what do we observe about geometric sequence? Anytime we see that what? Anytime we see that the common, there's a what we call the common ratio, right? So remember here we said this was common difference, D, right? So what do we observe about geometric sequence? So let me just give you an example of the sequence first, then we analyze it. Okay, so let's say we have this. You could already tell that what? In order to get the next term, we are multiplying by 2, right? And this is what we call the common ratio. So what happens is, anytime I observe this, the ratio of the second term to the first term is equal to the ratio of the third term to the second one, and so on and so forth. So basically, the ratio of 2 successive terms are always the same. So it's basically a constant. So anytime I observe this, we call this constant the common ratio. So anytime I observe this, then that will be a geometric sequence. You can see that this is a type of recurrent sequence as well, because the next term depends on the previous one, okay? So now what happens is, basically you are saying this is equal to R, which means B2 is just B1 times R. Again, you also know that what B3 over B2 is also equal to R, which means B3 is equal to B2 times R. And now you know what B2 is, which is B1 times R, so you can multiply that times R, that will be B1 R squared. So that is B3. So you can continue like this. B4 would be B3 times R, which will be what? B1 R squared times R, which is B1 R cubed. So when you notice this, we can continue like this inductively. You would have what? Bn would be what? B1 R raised to power what? N minus 1. Okay. If you observe this, you can see that what B4 is a B1 R raised to power 3. We reduce the 4 by 1. That's the relationship we can observe Also, we reduce the 3 by 1 here to get 2. So therefore, when we have Bn, we're going to reduce the power the power by what? By 1, right? So the power will be n minus 1. All right. Now we have the nth term of a geometric sequence. So a sister to this is, depending on what you are comfortable with, some people they prefer to use an and use a as the first term, and then they'll still have the same formula. So whatever you prefer to use. In some other cases, they use bn, b1. They use common ratio to be q, n minus 1. So whatever one you're comfortable with, you can use that depending on how you plant the subject. All right. Now this is the nth term. Okay. Now what about the sum of the first nth term, which means if I'm adding the first, just like the previous example in arithmetic sequence, let's say I am adding the first n terms together. What is the formula for this? It turns out that the formula is this: b1 multiplied by what? R raised to power n minus 1 over r minus 1. Now this is the common ratio, this is the first term. Now this is the simple formula for calculating the sum of the first n terms of a geometric sequence. Like I said, if you're working with a, that would be Sn equal to a r raised to power n minus 1 over r minus 1. And I have to say that what r must not be equal to 1 for this to work, because if r is equal to 1, denominator becomes 0, and that would affect and that would be undefined. Okay, good. So let's look at the example that we have before and just illustrate how to find this. So let's say this is your geometric sequence. Okay, now let's say we want to find B20, so the 20th term of this sequence, right? How do we find it? Remember the formula. B20 would be what? The first term, r raised to power what? N minus 1, right? 20 minus 1. So what is B1? B1 is basically 1 times r. What is r? Don't forget r is 2. 20 minus 1 is what? 19. So the answer will just be 2 raised to power 19, right? As you can see, right? This is the first one, this is the second term. So when you get to the 20th term, this will give us 2 raised to power 19. Okay, as easy as that. Now, the last step is, let's say I want to find the sum of the first 5 terms of this sequence. Okay, how do I find it? Now, let's do the traditional way, which is B1 plus B2 plus B3 plus B4 plus B5. Okay, now what does this mean? Now notice that what? B1 is 1, B2 is 2, B3 is 4, B4 is 8, B5 is what? 16. So you can literally add all of this together to get your S5, which is 3 plus 4, that's 7, 7 plus 8, 15, 15 plus 16, that is 31, okay? Right, that's 31. Now let's calculate it using the formula S5. We said this is what? B1 r raised to power n, r raised to power 5 minus 1 over r minus 1. So we know our B1 is 1, which is the first term. What is r? R is the common ratio, which is B2. So you can get it using any two successive terms, which is B2 over B1, which is 2 over 1, or B3 over B2, which is 4 over 2. So you can, so your r is basically this. So whichever one, which is 2, right? Now, which is 2 raised to power 5 minus 1 over r is 2 minus 1. So when you simplify the bracket first. 2 raised to power 5 is 32. 32 minus, so here this one is 32. 32 minus 1 is 31. So you have 1 times 31 all over 2 minus 1, which is 1. So the answer is 31 again, okay? So you have 31 as well. So with the formula and the traditional method, both of them match. Okay, now this is what this is the basics of arithmetic sequence and geometric sequence. Now let me tell you how the problems would come about so that you start thinking that way before we move to the last part of geometric sequence, which is sum to infinity, and then we cap the video there. And in the next couple of videos, I would start to solve the problems based on sequence and series. Okay, let's talk about how the problems usually comes. So that you can build the mindset on how to tackle them. So let's write the formulas. We said an is what? A plus n minus 1d. and then you have Sn, which is what? N over 2, 2a1 plus n minus 1 d. Okay, for the geometric, we said Bn is Arn minus 1, and then Sn would be given as what? Also, we said B1, sorry. So we said B1 r raised to power n minus 1 all over r minus 1. Please don't forget this formula. You have to memorize them, right? Very, very important. Now, how the problems arise is this. When you notice from these two formulas, let's say we are looking at this formula, okay? There we have how many different variables here? N is a variable, so you need to know what n is. The first term is another variable. The common difference is another variable, and then an is another variable. So you have 4 variables here. So what usually happens is from the problem, you would know 3 of this, 3 out of 4 of this, and they will ask you to find the 4th one. So let's say case 1, they might give you, let's say they give you A4. Let's say they give you A4 in a problem, okay? Now, what this means is what? You know what n is, which is 4, and you also know what A4 is, right? So you know 2 terms. Okay, now for them to ask you to find either the first term or the common ratio, they will have to give you one additional term. Let's say they'll give you the first term. Now, once you know the first term, it is now easy to find the 4th variable, which is what? The common difference. And this is what is paramount in most of the problems in sequence and series. Okay, so let's look at another case. So they could give you A1, A, which is the first term, A1, and they will give you n. So let me write Sn here too. Okay. So they'll give you n, right? And they'll give you the common difference, and they'll ask you to find S. Let's say Sn. Okay. Now notice that before you can find Sn, when you look at this formula, notice that what? You need n, you need to know what your n is, you need to know what your A1 is, you need to know what your common difference is. So you have to know the 3 variables, which is this. They will give you A1, they will give you the term that you need to find, and they will give you the common difference. An example is, let's say they ask you to find S5. Okay, given that A1 is 2, and then the common difference is -3. If you are given this, you know that what? This is sufficient to solve the problem, because you know the 3 things that you need to find the 4th term. I mean, to find the 4th variable. So you know 5, you know A, and you know common difference. Now, this is what is usually, what usually happens in most of the sequence and series problems, as you would see, and I'll be reminding you from time to time in the coming videos on the problem set on this particular topic. Okay, so I just want you to have the mindset of how these things operate. And finally, let's talk about the sum to infinity, which is the last part. And this is you also need to know a formula corresponding to this. Now, what is sum to infinity? So it is about a geometric sequence, a special type of geometric sequence. And what is the special case here? When we have the common ratio of this sequence to be between -1 and 1. So an example is this. Let's say I have a sequence given as this. Now, what is the common ratio of this sequence? It will be, don't forget, second term over the first term. That will be 1/2 divided by 1, and that will be 1/2. Now, because this common ratio is between 1/2 is between 1 and -1, it means that we can sum this. This implies that we can sum this sequence to infinity and get a particular value. So what does this mean? S to infinity is just basically the first term. So this is the formula for it. First term over 1 minus r. Okay, so this is the so B1, right? So if you are using A, that will be A over 1 minus r. Okay, so what it means is, for this particular sequence, I can find the sum to infinity, and the formula is given as this. What does this mean? A is the first term. In that example, A is 1. The common ratio is the next variable that you need to know. In that case, it is 1/2. Don't forget how to find the common ratio is 1/2. Now, what is the sum to infinity? It means when I add all the terms of this sequence up to infinity, I would get 1/1 minus 1/2, which is 1/1/2, which is equal to 2. So what this means is what? So let me express what the sum to infinity means. It means when I add all the terms of this sequence, not up to n, but up to infinity. The only time I can add this, I can add the terms of a geometric sequence up to infinity, and for me to have a value is if the common ratio is between 1 and -1. If the common ratio is outside of this range, it means that what? We cannot sum to infinity, right? Note that we can't sum to infinity if our common ratio is not between -1 and 1. So this is not the right way to write it. So let me just put it as an interval. If it's not between -1 and 1, then we cannot sum to infinity. I hope you take note of that. That's the first prerequisite to the condition to know whether you can sum this sequence to infinity or not. And this is only applicable to what? Geometric sequence, not arithmetic. Okay? So Bn is geometric. All right. So this would be the end of the video. I hope you find this video interesting and you also find it educating as well. In the next couple of videos, I would go over the problems that you have in the problem sets for sequences and series. And I hope to see you in the next video. Stay tuned.